Hey everyone, in this video I'll show you how to make your own bubblegum simulator game. Make sure you watch to the end so you don't miss a thing. If you want the model I've created in this video, or you want the higher quality version, you can check them out on my Patreon. Members also get access to an exclusive channel on the Discord server where you can send your video ideas. I'll be looking at these video ideas first, so if you want me to make a video idea soon, this is perfect for you. In the replicated storage, create a folder. Name it Flavors. This will contain all the flavors in the game. Each flavor will be contained in a separate folder. Let's name the first flavor Starter. This will be the flavor the player starts with. Inside, create an int value. Name it Bubbles Per. It tells us how many bubbles a player gets from blowing once. I'll go with 4. Now create a string value. Name it Image ID. It will contain a reference to the image we want to display on the GUI. We can look for an image in the toolbox. Once you've found one you like, click the 3 dots and select Copy Asset ID. Now we can paste it into the value. We also need to prefix it with rbxAssetID: whenever we're referencing an asset uploaded to Roblox. Now head to the workspace, create a model, name it Bubble. Inside, create a part, set its size to 1 on everything, then set its shape to ball. We can change its color, material and transparency. This is how the bubble will look for the starter flavor. The way we'll change its size is with the model's scale property. This will multiply the size of the ball by whatever number we put here, which is why we set the size of the ball to 1. We need to disable collisions, so turn off Can Collide. We can also turn off Can Touch and Can Query so the bubble doesn't interfere with touch events or raycasts. Then set massless to true so the bubble doesn't affect the character's physics. Now parent the model to the starter flavor folder. Let's duplicate the folder to make another flavor. I'll name it Common. Let's change the bubbles per value. We should also find a different image. And let's also change the appearance of the bubble model. Now create an int value. Name it Cost. It will contain the price to purchase the flavor. We don't need a cost value in the starter flavor since every player owns it from the start. Let's make a couple more flavors. For this final flavor, I want to add some special effects. Inside the part, create an attachment. Inside that, create a particle emitter. Set locked to part to true, so the particles stick to the part. I'll also set its speed to 0. Let's set some points for the size to animate it. And the same for the transparency. I'll just readjust the brightness. And finally, I'll use the image from the image ID value as the texture. Now we have a nice glow around the bubble. The particle emitter will also change size when we set the model scale, so we don't need to worry about that when we do change the scale. Now duplicate the flavors folder. Name this one Storage. We can delete the bubble models from each folder. Rename bubbles per to storage. These values tell us the maximum number of bubbles a player can store. Let's adjust the values. I'm going to keep the same names and images for the storage and flavors, but you can change them to whatever you want. In the server script service, create a script. Open the toolbox and go to the models page. Search for profile service. Find the one made by Lotus. Click Insert and drag the module into the Game Manager script. We'll use this module to handle data stores. We specifically want this because it handles session locking for us. Session locking is what prevents a user from joining the game and loading outdated data, which could cause duping items like pets. Let's look at an example. I decide to trade with my alt account, I give them my pets for free. Then I leave the game will start to save my new data to the data store. If I'm quick enough, I can rejoin before my data is saved. Without session locking, I'll load in with my old data, which is the data I had before trading with my alts. So now I have my pets in my main account and my alt account. Once I leave the server, I'll overwrite whatever data is saved with my duped pets. With session locking, when I rejoin the game will notice that my data is still being saved, so I won't be able to load my data until the game has finished saving whatever data I had when I left. Before we do anything, first publish the game to Roblox. Then in the game settings, go to security. We need to enable Studio access to API services, which allows us to use data stores to save data. Now in the replicated storage, create a folder called Game Properties. This will contain information about the game that needs to be accessed by multiple scripts. The first values we need will define the names for the folders containing the player's stats. Each player will have two stats folders. One will be the leader stats folder, so we can display stats in the player list. In Bubblegum Simulator, this is used to display the number of eggs hatched and the number of bubbles blown. Then we need another folder that will contain the other values we don't want displayed in the player list. In this folder, we'll have the player's cash, current amount of bubbles held, owned storage and flavors, pets, items, and whatever else a player can have. For this video, we won't be doing the pets, so let me know if you want a second part by hitting the like button and dropping a comment. First, we need a string value called stats. Make sure its value doesn't match anything else stored in the player. Then, to stay consistent, let's make a value for the leader stats folder. Its value must be leader stats, all in lowercase. Make a value for the current bubbles a player has. And also for the current cash a player has. Now let's make the value for the total number of eggs a player has hatched. Since this will be displayed on the player list, we can add emojis to make it look nicer. Because we're relying on these values for the names of the player's stats, we don't need to worry about using special characters or emojis. Make a value called items. This is the name for the player's items folder, which will contain their own storage and flavors, and in the future things like pets or potions. Now make a value for the owned flavors folder, and for the owned storage folder. We also need a value for the total number of bubbles blown. It will also be stored in the leader stats folder, so let's find an emoji for it. The last value we need is called unlocked zones. This will contain the zones a player has unlocked. First we need the player's service. Now let's get the game properties folder. We should also put all these values in its own folder, since we'll have other values in the game properties folder. Let's name this folder stats. Now retrieve the folder in the script. We need the profile service module. Then we can define a template. This is the default data that will be chosen if no data is available. This means a player has no data, so it's playing for the first time. So all this data is the data players start with. We could say something like cash equals 0, which is completely fine, but just to be extra careful so we don't make any typos, we can instead use the name of one of the values in the stats folder. This way we'll always know if we made a typo, since the script will produce an error message telling us that whatever value we're trying to access is not a valid child of the stats folder. If we just use strings, if we do make a typo, the script won't know, and whatever is using that data will either be given nil or the wrong data. Let's do the same for the other values. For the owned flavors, it will be a list. Inside the list will be the names of any owned flavors. In this case, we want players to have the starter flavor when they start. If you've named it something different, make sure you use that name. Do the same for the owned storage. We also need to store the equipped flavor. For the key, we'll simply prefix the value name with the word equipped. Since the player can only equip one flavor at a time, we just need to store a single string, which is the name of the equipped flavor. Again, we want to set it to the starter flavor for first time players. Do the same for the equipped storage. For the unlocked zones, we'll also store a list. Inside will be strings representing the names of zones. First time players won't have any unlocked zones, so we'll leave the list empty. Now let's get the store containing player data. For the key, I'll use player data. Then we need to give the template. Let's make a list to store each player's profile so we can access it easily after we load their data. Now make a function to load the data for the player. Here I'm just using the example code from the profile service documentation. In this block, we've successfully loaded the player's profile. We can return the data here, although we don't need to since we've stored the player's profile in the profiles list. Make a function to respond to when a player joins the game. Inside, we'll get their data. If the function doesn't return data, in cases where a player rejoined too fast, for example, we'll just return. For now, we'll just print the data, connect the function to the player added event of the player's service. Now let's test the game. In the output, you should see a table printed. Let's open it up. We can see all the fields have the values we defined in the template. Before we do anything with the data, let's get the storage and flavor folders. Make a function to create a player's stats from their loaded data. We can replace the print with this function. Inside, make a new folder. Set its name to the value held in the stats value. Do the same for the leader stats folder. Now let's make an int value for the total bubbles blown. We can set its value to the loaded data. Finally, parent it to the leader stats folder. We need a way to update the player's profile data whenever this value changes. Create a function called bindValueToProfile. It will take a value, the player's profile data, and the key associated with the value. Inside, we'll use the getPropertyChangeSignal function for the value property. This means we'll have an event that fires whenever the value property is updated. Whenever it fires, we want to update the value in the profile. What you see in the output is what would be passed as the profile parameter, and we might pass bubbles as the key if we want to update the bubbles value. Let's call this function for the total bubbles value. For the key, we'll use the name of the stats properties value. Copy this code for the total eggs hatched value. Do the same for the cache value. This time, its parent will be the stats folder. Copy it once more for the current bubbles value. Let's parent the leader stats and stats folder to the player. Test the game to make sure everything's working. In the Explorer, open up the player. Inside the leader stats folder, we can see two values, and inside the stats folder are the other two values. Let's head over to the server view, change some of the values. Then let's leave the game and rejoin. The data has been saved. Let's make the items folder. Parent it to the stats folder. Make a folder for the player's own storage. Parent it to the items folder. Now we'll iterate over every string in the player's storage data. For each string, we'll retrieve the storage folder in the replicated storage. We can make a function to handle creating item values for us. This function will be used for both the storage and flavors. It will receive the item folder in the replicated storage, the owned folder in the player's item folder, the data section of the player's profile, and the key in the data table where the equipped item is stored. First, make an object value. Set its value to the item folder in the replicated storage. Now we'll check if the equipped item in the player's data matches this item. Since players can only have one flavor or storage equipped at a time, to keep track of which item is equipped, we can just set the name of the equipped value to something we can recognize and make sure the rest of the values don't have that name. The name we'll use is equipped. Now we'll listen for when the value's name is changed. We only care about if the name has changed to equipped. If it has, we'll replace the equipped item in the player's data table. Finally, parent the value to the player's owned items folder. And we can also return the value in case we want to do something else with it later. Back in the for loop, let's use this function. Replace the arguments with the appropriate ones for the player's storage. Now do the same for the player's flavors. Let's test to make sure it works. The values named equipped both point to the starter items as expected. Now let's make the unlocked zones folder. Parent it to the stats folder. Again, we'll use a for loop. For each zone name, we can create any kind of object. The important thing is that we set the object's name to the zone name. This way, we can just look up the name in the folder using something like find first child. When we test the game, we shouldn't have any zones in the folder. We can also return the stats folder and leader stats folder. In the starter GUI, make a screen GUI. This will be used to display our stats. Make a frame called container. I'll place it to the left. Inside, create another frame. Name it Bubbles Container. Let's duplicate it and place it under. This one is called Cache Container. Let's change the colors so we can see each frame. Inside each frame, we need a text label. Now in the screen GUI, create a local script. First, let's get the game properties and stats folder. Then get the client. Now we can get the player's stats folder. We need the bubbles value, cache value, and own storage value. We also need the GUI components. First, let's make a function to update the cache text label. Inside, we can simply set the text property of the label to the value property of the cache value. Let's call the function initially so we can set up the text label. Now make a function to update the bubbles text label. First, we'll get the player's equipped storage. We can get the number of bubbles from the bubbles value, and we can get the max storage for the storage value in the equipped storage folder. Then we'll set the text to these two values separated by a slash. We also want to call this function initially, and whenever the bubbles value changes. The text label also needs to be updated when the player equips a new storage. In the function, we can listen for whenever the equipped storage has a name change. Rather than connect, we'll use once. Similar to connect, it binds a function to an event. However, when the event fires, the connection is automatically disconnected for us. We want this to happen because we don't care about the name of a storage once it's no longer the equipped storage. And when the event fires, we'll call the update bubbles function. This would be okay if we just ran this function a single time, but we're also running this function whenever the bubbles value changes. This means we could have multiple connections on the same value, which is unnecessary. So let's make a variable to store the connection. At the start of the function, we'll check if the variable stores anything. If it does, it means there's an active connection, so we can disconnect it. Let's run the game to make sure it works fine. In the output, we can see an error. It tells us that the stats folder doesn't exist in the player. This isn't because we aren't creating the folder. We've seen before that the folder is created properly. This is an issue with the character spawning in before the data loads. Because loading data can take some time and we're creating the stats folder after loading the data, it's possible the character spawns in before we create the folder. A simple fix is to disable character autoloads. This means the character won't be able to spawn unless we write code to spawn them manually. Head over to the server script. We only want to spawn the character after we create the stats folder, so let's call the load character function to spawn them in. There's still one issue. If a player dies, they won't be able to respawn. We can fix this by listening to the character added event. This fires whenever the character spawns in. Inside, we need the humanoid. It has the died event, which allows us to listen for whenever the character dies. Inside, we can simply call the load character function. You can also choose to add a wait if you don't want respawning to be instant. Now let's test the game. There's another error. This time it's just a typo. Now everything's working. Let's try changing our stats. We don't need to switch over to the server view since any changes we make on the client will be seen by the local script. The text label changes to the value we set. We could make this look nicer by adding commas to the number. In the replicator storage, make a folder called modules. Create a module script. Name it util. This will contain various functions that aren't linked to any single part of the game. Right now we need a function to add commas to a number. This function is something that can be used in many places, such as the GUI we just made, and anywhere else we need to display large numbers. We'll use a recursive function to add the commas. The base condition will be that the number is less than 1000. If a number is smaller than 1000, we can't add any commas to it. In that case, we'll just return the number as a string. The recursive case will call this function on the number divided by 1000. We also want to round it down to get rid of any decimals. Then we'll append a comma to it. And we'll also append the last 3 digits. Let's visualize this function. First we'll input a number less than 1000. It will just return that number. Now let's try something larger. If we divide by 1000, we get 12,345.678. Then we round it down to get 12,345. So we'll pass that to the function, and right after that we'll have a comma and the last 3 digits of the original number, which is 678. Let's follow the recursive case. The number 12,345 is not smaller than 1000, so divide by 1000 and round it down to get 12. We'll pass 12 to the function. Right after that, it's a comma and the last 3 digits, so 345. Let's again follow the recursive case. 12 is smaller than 1000, so that will be returned. 12 is combined with a comma and 345, then that is combined with a comma and 678, then that is returned as the final result. In the local script, we can require the module use the function for the cache label, let's test to make sure it works. No commas are added for these small numbers. As soon as we go over 1000, a comma is added, and for very large numbers, a comma appears every 3 digits. Now that we know the function works, let's also apply it to the bubbles label. Let's handle the client-server communication. First, we'll need a folder to store our remote events. For now, we just need a remote event for blowing bubbles. In the game properties folder, create a number value. Name it blow rate. This is the cooldown time in seconds for blowing bubbles. I'll go with 0.5 seconds. Let's first get the remote events folder and the remote event. Then we need the blow rate value. Each time the remote event is fired by a client, it means the player is trying to blow a bubble. We need the player's bubbles value and their equipped flavor and storage. We also need the total bubbles value. Now let's calculate the amount of bubbles a player can blow. We want to use math.min so we can limit the number. This function takes some numbers and will return the lowest number. The first number is the bubbles per value of the equipped value. We'll usually be incrementing by this amount, but if the player's storage is almost full, we don't want to exceed the maximum storage. In that case, we want to use the difference between the current bubbles and the maximum storage. If the storage is already full, we'll get 0 as the increment. It's also possible to get a negative number if the player has blown bubbles and then equipped a smaller storage. In both cases, we don't want to do anything, so just return. Now let's add the increment to the bubbles value and total bubbles value. We also need to add some cooldown on the server. This will prevent a cheater from spamming the remote event to instantly fill up their storage. Create a table to store each player and their cooldown state. When the remote event fires, we'll first check if the player is on cooldown. If not, we'll set them on cooldown. At the end, we can wait for the blow rate value before taking the player off cooldown. We'll be handling a cooldown on the client side too, so we need to make sure the cooldown state on the client matches the cooldown state on the server. For example, a client fires the remote event at 0 seconds. The client puts itself on cooldown. At 0.1 seconds, the server receives the message. The client puts itself off cooldown at 0.5 seconds. The client then tries to fire the remote event again, but on the server, the cooldown has only lasted 0.4 seconds, so the remote event won't be responded to. To avoid this, we can reduce the cooldown time on the server by some amount. Let's call this amount the leniency. The more we increase this amount, the less likely a regular player's message isn't rejected, but it also means cheaters can fire the remote event at a higher rate. I'll go with 0.2 seconds of leniency. Now we just need to subtract it from the normal cooldown time. We can test this using the command bar. When we fire the remote event, we can see the bubbles change. I'm spamming the remote event, but the value only changes periodically due to the cooldown. And once we reach the maximum storage, we can't go any further. Now let's make the client interface for blowing bubbles. In the starter GUI, create a screen GUI. Make a frame. I'll place it towards the bottom right. Name it Bubbles Container. This is why the bubble pop-ups appear whenever the player clicks to blow a bubble. Set its background transparency to 1. Make another frame. Name it Bar Container. This will display the progress bar. I'll place it in the bottom center. Inside, make another frame. Name it Bar. This is the background of the progress bar, so let's give it a dark color. And inside it, create another frame. Name it Fill. This is the actual progress bar, so let's give it a bright color. In the bar container frame, we can add a text label for decoration. I'll set its text to blowing, followed by 2 dots. Let's go back to the bubbles container frame. Inside, create a frame. Add a UI aspect ratio constraint to ensure it has a square ratio for all screen resolutions. Let's name the frame Bubble Container. Inside, create a text label named Bubbles Increment. This will display how many bubbles the player will get from blowing once. Now create an image label. Let's find an image to use. We need to put the text label above the image label, so set its Z index to something higher, like 2. Since it's a bit hard to read the text, we can change its font and color. Then we can add a UI stroke. Let's also hide the background of the frame. This is something we're going to create copies of during the game, so we need to store it somewhere else to access when we need it. Let's make a folder in the replicated storage called templates. Drag the frame into the templates folder. And let's put that into another folder for better organization. Now create a local script in the screen GUI. First we need the context action service, which we'll use to detect when the player is holding their mouse down. We also need the run service so we can check the mouse state and respond quickly when it's pressed down. Make a variable to store the mouse state. Then we need a function that we'll pass to the context action service. It'll receive 3 parameters from the context action service. We can make the variable equal to the condition that the input state is not end. End means the user is letting go of their mouse, so we want the opposite of that. We can use bind action to run this function. Pass false because we don't want a mobile button to be created. Then we can pass mouse button 1 as well as touch to include mobile users. Now we can listen to the run service's heartbeat event, which fires every frame, so approximately 60 times a second if your game is running at 60 FPS. It gives us a parameter called delta time. This is the time in seconds between when the previous heartbeat event fired and when this heartbeat event fires, which is also the time it took for a single frame to pass. For now, let's just print the isHolding variable. Let's test the game. At first, we'll see false in the output as we aren't holding the mouse button. Once we start holding it, true is printed. Now let's get everything else we need. First we'll need the tween service, which we'll use to animate the bubble pop-up. The bubble pop-up has 2 stages. The first is the rise stage, where the bubble's position will move up. The second is the fade stage, where the bubble will fade away after some time. Let's make tween infos for both stages. We need the util module so we can add commas to the bubble's increment. Then get the remote event. We need the blow rate as well as the stats properties. We also need the pop-up template. Now let's get the player. We need the bubbles value, the owned storage folder, and the owned flavors folder. Finally, let's get the GUI components. Set the visible property of the bar container frame to false, so it's hidden at first. To handle the cooldown, we'll make a variable. Its value will be the blow rate amount. Let's make a function to count the number of bubbles the player will get from blowing. We're going to use the same logic as we did in the server script. Now in the heartbeat connection, we'll call the function. If the increment is less than or equal to 0, we don't want to continue. We also don't want to continue if the player isn't holding the mouse down and the cooldown variable is set to the blow rate amount. The second condition requires the cooldown to be set to the blow rate amount because players should be able to click once to blow a single bubble. Without this, the player would have to hold for the entire 0.5 seconds before we fire the remote event. Before we return, reset the cooldown variable to the blow rate amount. Each time the event fires, we can subtract the delta time from the cooldown variable. Eventually, the cooldown variable will become less than or equal to 0. At this point, we can fire the remote event. We also need to increment the bubbles value on the client. This is because the remote event could take longer than the blow rate amount, so the client might think it's ready to blow another bubble, when in reality the player has reached their maximum storage, so the client will do all the effects but won't see any changes to the value because the server has rejected the message. After blowing a bubble, we can reset the cooldown variable. Let's test the game. I'm already at full storage from the last time I tested, so let's set the bubbles value back to 0. Now when I hold the mouse down, my bubbles increase. Now we'll make the pop-up effect. We first need a random variable. Create a function to make the pop-up. It will take the bubbles increment. First copy the template. Then we can set the text label to the increment. Now let's generate a random position. All we need to do is pick a random number from 0 to 1 for both axes, since we're using the scale component. Let's create the first tween for the rise animation. For the position, I'll keep the X position. And subtract 1 from the Y position. This means the position will go up by the height of the bubbles container frame. Then parent the copy to the bubbles container frame. I'll wait 1.5 seconds before doing the fade tween. That's because the rise tween has a duration of 2 seconds and the fade tween has a duration of 0.5 seconds. First I'll do the image label. We'll set the background transparency to 1, then set the image transparency to 1. Next we'll do the text label. We'll change its background transparency and text transparency. Now let's wait for 0.5 seconds, which is the duration of the fade tween, before deleting the pop-up. Inside the heartbeat event, let's call this function. Let's reset the bubbles value. Now whenever I blow a bubble, the pop-up appears and tells us how many bubbles we get. There seems to be an error. It's telling us that the frame doesn't have a child named Bubble. That's because I forgot to rename the image label. There was one more issue where the Bubbles container frame changed positions. This is just a typo. I've changed the position of the Bubbles container frame instead of the pop-up frame. Now it works fine. The fade looks a bit strange. That's because we aren't changing the transparency of the UI stroke. Let's make a tween for the UI stroke. We just need to change the transparency property. It's also annoying having to set the values to 0 every time we want to test, so go to the server script. We can generate a random key each time using the HTTP services generateGUID function. This will return a string that is universally unique, so we're guaranteed to get a new key each time. We can remove this later when we need to test the saving functionality. Now the fade effect looks good. Let's do the progress bar now. We'll set the visibility of the bar to true. Then adjust the fill size. For the X scale, we'll base it on the cooldown. We want to subtract it from 1, so as the cooldown gets smaller, the bar gets larger. We also want to make sure the cooldown is never smaller than 0, or the bar might overflow because its size is greater than 1. For the Y scale, we'll just use 1. And when we return, we want to make the bar hidden again. Let's test the game. Having the bar disappear instantly looks a bit strange. We can add a pause before hiding the bar. Before hiding the bar, we need to make sure the player hasn't started blowing bubbles again. If they have, the cooldown variable won't be at the blow rate amount anymore. Now it looks much smoother. Now we need to handle selling bubbles. To keep things simple, we'll just have a single cell area. We'll add more cell areas when we make the zones. In the game properties folder, create a number value called cash bubble ratio. This is the amount of cash players get for every bubble. I'll set its value to 2, so the player gets 2 cash per bubble. Then in the workspace, create a folder named cell. Make a part. Name it hitbox and put it inside the folder. This is the part that the player has to touch to sell their bubbles. Let's make it semi-transparent and give it a red color. Make sure can collide is off and anchored is true. I'll also make it a cylinder. Let's go back to the server script. Now let's get the cache bubble ratio. We also need the cell hitbox. In Bubblegum Simulator, a player can sell their bubbles periodically by standing still in the cell area. They also don't have to move around to keep firing the touched event. To do this, we'll make use of the touch ended event too. Each time we detect a body part of a player's character has entered, we'll add it to a list. Then each time we detect a body part has left, we'll remove it from the list. As long as the player has at least one body part inside the cell hitbox, we can periodically convert their bubbles to cache. Let's make a table for the body parts inside the hitbox. Then make a table to store the player's cooldown states. First, let's listen to the touched event. We'll look for a player from the parent of the touching part. If there isn't one, we can return. Now we need to ensure the touching limbs table has a list for this player. If not, we can make a new one. Then we'll search the list for the touching part, which will be a character's body part. If it's inside the list, return because we've already added this body part. Now we need to check the length of the list. If it's greater than 1, this isn't the first body part to have entered the hitbox. If so, we'll return since we've already started the loop for selling. First we need to check if the player is already on cooldown. If so, we need to wait for the cooldown to end. Then get the player's bubbles value and cache value. Now let's write the cell loop. First check if the cooldown is active. If it is, let's wait for a second. You can change this to however long you want the cooldown to last. Then set the player to null in the cooldown dictionary, which ends their cooldown. We'll return if the player is no longer touching the hitbox. Now let's make the player's cooldown active. Before selling, make sure the bubbles value isn't at 0. Now let's add to the cache value. Then set the bubbles to 0. Now listen for the touch ended event. We'll again search for a player from the touching part's parent. If the player doesn't have a list in the touching limbs table, we can just return. Now we need to find the index of the body part in the list. If we can't find an index, the body part isn't in the list, so we can return. Then let's remove the item at that index. And if the length of the list is 0, we can remove the list, which will tell the cell loop to stop. Let's test the game. Now let's set up the zones. We won't be handling unlocking zones yet, but we need to define the zones so we can make the shop. In the game properties folder, create a module script. Name it zones. First we need the stats properties. Now let's define the zone names. For the heights, we'll map the zone names to numbers. I'm indexing the zone names list in case I decide to change the name of a zone later on. Now let's define the storage locked behind zones. For the key, I'll use the storage value in the stats properties. Inside, we'll map the zone names to lists. Each list will store the name of the storage that can only be bought once you unlock the zone. Let's do the same for the flavors. We also need a function to find the zone of an item. It'll take the name of the item and the key, which is either the storage value or flavors value in the stats properties folder. We can get the table for that item from the key. Now iterate over each mapping. If we can find the item name in the list, we can return the zone name. In the remote events folder, create 2 remote events. Name them equip flavor and equip storage. In Bubblegum Simulator, when you buy a flavor or storage, it automatically equips it for you. This means we can combine buying and equipping into a single remote event, and we'll check if the player needs to purchase the item before equipping it. In the server script, let's get the zones module. Then we need the 2 remote events we just made. Let's make a general function to respond to both remote events. It'll take the player, the item to equip, and either the storage or flavors value in the stats properties folder. First, let's get a reference to the player's data, since we'll need to update that once the player equips the item. We also need the player's cash value if the player needs to buy the item first. And we need the owned folder for the given item to check if the player already owns it. Finally, we need the player's unlocked zones, which we'll look through before letting the player purchase the item. In the util module, let's make another function. This will take a player's owned folder and an item folder from the replicated storages, flavors or storage folder. It will look for a matching value, which we'll use to determine if the player already owns that item. Inside, we'll simply loop over every value in the owned folder. If the item and value match, we can return that value. First, we need to require the util module. Now let's use the function to look for the value. If it exists, the player already owns this item, so we just need to equip it. Let's make a function to equip an item. It'll take the value to equip and the folder containing all the values. First we'll set the name of the currently equipped value to something else. Then we'll set the name of the given value to equipped. Now we can call the function to equip the value. Otherwise, the player needs to purchase the item. First, we'll get the zone for the item. If there's a zone and we can't find it in the player's unlocked zones folder, we'll return since the player hasn't unlocked the zone yet. Now we need the price of the item. If it's greater than the player's cash, we can also return, since the player doesn't have enough cash to buy it. Finally, we can deduct the price from the cash value. Then we'll use the createItemValue function we made earlier. And we can call setEquipped on the new value. Now we need to update the player's data. We just need to insert the name of the item into the player's list of owned items for the given item type. Now we can respond to onServer event for the equip storage remote event. The client will give us the name of the storage to equip. First we'll get the folder for that item in the replicated storage. Then we can call the equipItem function. Do the same for the equip flavor remote event. Before we test, let's comment out the part that generates a new data store key. Let's test using the command bar. Let's try firing the remote event to buy something we can't afford. Nothing happens as expected. Let's change the cash value. Now if we fire the remote event, we can buy the item. The starter flavor has had its name changed, and the new flavor's name is equipped. The amount of bubbles we get has also changed. Let's try to buy something from a zone we haven't unlocked. Nothing happens as expected. Let's manually create the value in the unlocked zones folder. Now we can buy the item. Let's also make sure the items have saved. Now we'll make the shop GUI. Inside, create a frame, name it container, Inside that, create a frame named selected container. This will display the selected item. Make another frame, name this one flavors container. This will display the flavors page of the shop. Let's also add the button to open the flavors page. Create another button for the storage page. Create a third button. This will be used to close the shop. Inside the flavors container frame, let's add a text label. This will be the title. Create a scrolling frame. Set its canvas size to 0 on everything. Set its scrolling direction to Y. Set its automatic canvas size to Y. Inside, create a UI grid layout. This will automatically position the flavors in a grid. To determine the right size, let's first create a button for a flavor. Name it Item Button. Inside, create an image label. Name it Item Image. Create a text label. Name it Item Name. Create another text label. Name it Item State. This will display the price of the item. If the player owns the item, it will display either owned or equipped. Let's duplicate it a bunch so we can see how the grid will look. Now let's adjust the cell size of the UI grid layout. I'll go with 0.3 recurring to fit 3 buttons in one row. It isn't exactly square, so I need to adjust the height. When we create enough buttons to need a scroll bar, we can see the scroll bar covers some of the buttons. In the scrolling frame, we can set the vertical scroll bar insert property to scroll bar, meaning the buttons will be squished to the side to make space for the scroll bar. Let's delete the duplicates. Now put the button in the templates folder. Let's also make a separate folder for the button to keep things organized. Copy the flavors container frame. Let's hide the original. Name this one storage container. This will display the storage page. Let's change the title. Inside the selected container frame, create an image label. Name it item image. This will display the image for the selected item. Then create a text label. Name it item name. This will display the name of the selected item. Create another text label. Name it item stats. This will display the amount of bubbles for flavors, or the maximum bubbles for storage. There are 3 different states we can display. We'll make separate frames for each state. The first will be for buying. This requires the player doesn't own the item and has unlocked the zone it is in. Inside, create a button. Name it Buy Button. Let's hide the backgrounds of the text labels, and I'll make the buy button smaller so we have space to display the price. Let's create the price text label. Name it price text. I'll also create another text label for decoration. Let's duplicate the frame for the next state, hide the original frame. This state is for an item the player owns but is not equipped. We don't need any text labels here, I'll just keep one for decoration. And I'll change the buy button to an equip button. Duplicate it again. This state will be for an item the player has equipped. Everything inside here will be for decoration. I'll add some text saying equipped. And I'll hide the backgrounds for each frame. There is one more state we need to do, which is the locked state. Instead of duplicating one of the other states, we can group everything we have right now into a single frame called unlocked. Make sure the frame has a scale size of 1 for both axes, so the elements inside the selected container don't change size when we reparent them. Now drag everything into the frame. Create a second frame inside the selected container frame. Name this one locked. I'll make its background invisible. Again, set its size to 1. Inside, we want to display the name of the zone needed to unlock the item. Create a text label named zone name. Now we can add some other elements for decoration. I'll also add a lock icon. Finally, we should add a UI aspect ratio constraint to the container frame. This will preserve the aspect ratio of the entire GUI, so we don't have to worry about the item buttons having weird ratios when the player's screen size ratio is different. In the screen GUI, create a local script. First, let's get the util module. We also need the storage and flavors folders in the replicated storage. Then we need both the zones module and the stats properties folder. Get both equip remote events. Then get the item button template. Now we can get the player's stats. We need their cash value so we can check if a player can afford an item. We need their owned storage and owned flavors folders to check if an item is owned or equipped. We need the unlocked zones folder to check if a player can buy an item locked in a zone. Now let's get the GUI components. I'll manually hide the GUI. The first thing we'll handle is closing and opening the shop. Closing is simple, we just need to set enabled to false. Now we can call this function in response to the mouse button one click event of the close button. When we open a GUI, we don't want other previously opened GUIs to stay visible, otherwise they'll end up stacking, which looks very messy. We can prevent this by creating a separate handler for opening menus. To communicate to the handler, we'll use a bindable event. Let's name it Open Menu. Create a local script inside. Get the bindable event. Then we need the client's player GUI. We need to specify which GUIs are considered menus. If we don't, we'll end up hiding things like the cache display. The only GUIs we want to consider as menus are the ones that cover the center of the screen. Right now, the only GUI that satisfies this is the shop. Now we can listen for the event. When firing it, we'll pass the menu we want to open. We can also pass null if we want to hide all open menus. Inside, we'll iterate over every menu in the list. We only want to show the provided menu, so we can set the enabled property to the equality between the provided menu and the menu being iterated over. To open the shop, players will do the same as when selling. Let's duplicate the sell folder, rename it to buy. Let's hide all the GUIs so we can see the buy hitbox. Let's move it to the side. I'll give it a green color. Let's enable the GUIs again. Open the shop handler script. First, let's get the buy hitbox. We're going to use similar logic as we did for the sell hitbox, so let's create a list of all the body parts touching the hitbox. We'll need the character's humanoid. The humanoid has its own touched event that fires whenever a body part in the player's character touches something. The event gives both the touched part and the body part. This way we can ignore when other players enter the hitbox. First, make sure the touched part is the buy hitbox. Also make sure the body part isn't already in the list, which would mean it's already touching the hitbox. Now we can add it to the list. Then we can check if we should open the shop. We only want to open it if the body part is the first one to enter the hitbox. We also don't want to open it if it's already opened. To open it, we need the bindable event. Fire it, giving the shop GUI. Now let's handle the touch-ended event. The humanoid doesn't have a touch-ended event, so we need to use the hitbox's event. First, we'll look for the index in the touching limbs list. If it exists, we can remove it from the list. And if the list is now empty, we can close the shop. Let's test to make sure it works. Opening and closing works when I run in and out. And if I close the shop while inside the hitbox using the close button, we have to walk out and back in again to open it. Now let's set up the flavors and storage buttons. First, we'll make a function for opening the flavors page. Inside, we'll just make the flavors container frame visible and the storage container frame invisible. We also want to change the look of the buttons to make it more obvious which page is open. Here I'll just change the button's background color, but you can add whatever changes to the appearance that you want. Then we need to change the appearance of the storage button. I'll choose a darker version of the button's color. Let's copy this for opening the storage page. Swap the visibility changes. Let's set the color of the storage button back to normal. Then use a darker color for the flavors button. Now let's bind these functions to their respective button's click event. And finally, we should open one of the pages as soon as the script runs. If we don't, when the player opens the shop for the first time, they might see something strange because we haven't opened either of the pages yet. I've run into this error when testing. It says the hitbox part doesn't exist in the buy folder. This is because of a property called streaming enabled. Streaming enabled loads and unloads things like parts depending on how far they are from the character to try to improve game performance. Although it's useful, it's tricky to work with, as you can see from this error. We can just disable it. Let's play again. When I open the shop, the flavors page is selected. We can click on the buttons to switch between the pages. I should also change the storage page's background color to match the button. Before creating the item buttons, we need to sort the items. Items should be sorted depending on their price and zone. Let's make a function to determine the lower between two items. First, we need the zone name for each item. We'll use the getItemZoned function we made in the zones module. It needs the name of the item and the key, which is one of the two stats properties values. Copy the code for the second item. Now we need to get the heights for each zone. Because some items don't have a zone, which means they are unlocked by default, we'll provide a default height of 0. We only want to return a result if the two heights are different. If they're equal, we should consider other properties instead, such as the price. The return value will be true if the first zone is at a lower height, which will tell the sorter to put item 1 before item 2. Now we'll compare prices. Again, some items may not have prices, specifically the starter items, so we'll use a default price of 0. And we'll return true if item 1 costs less than item 2. We could go even further and compare properties like the item names, but that shouldn't be necessary as we don't have any items with the same price. Now make a function to create the item buttons for one of the pages. It needs the scrolling frame to put the item buttons in, the folder in the replicated storage containing all the items, and the player's owned folder for the item type. First, get a list of all the children in the items folder. These children are all of the items we want to display in the shop. Then we need to sort the list using the sort function we wrote. Once sorted, we can iterate over the list, which will follow the order it's been sorted in. Make a copy of the item button template. Let's set its image and name text. We also want a way to find which item the button is displaying. We can do this with an object value. Name it item, all in capital letters. Set its value to the item. Then parent it to the item button. Finally, parent the item button to the scrolling frame. Now we can call the function for both the storage and flavors pages. The buttons have been created. We haven't displayed their states yet, so it says equipped for all of them. I've also forgotten to remove the item button's text, so I'll do that now. Let's handle selecting item buttons. First, we need functions to change a button's appearance between selected and unselected. For unselected buttons, I'll use a grey color. For selected buttons, I'll use white. We need an item state when displaying the item buttons and when selecting an item button, so we should make a separate function for it. It needs the item itself and the player's own folder for the item type. First we'll get its zone. Let's just copy this code. We need to check if the zone is locked. First make sure a zone exists for the item, and if it does, then make sure we can't find that item in the player's unlocked zones folder. If so, we can return a string with the text locked. Then we need to check if the item is owned. We can use the util module's findItemValue function. If the player owns the item, the value in the player's owned folder will be returned. If so, we then need to check if it's equipped or not, which is just checking if the value's name is equipped. If it's equipped, we'll return a string with the text equipped. If not, we'll return a string with the text owned. After that, the remaining case is that the player can buy the item. This can be broken down into affordable, meaning the player has enough cash to buy the item, and expensive, meaning it costs too much for the player. So let's get the price of the item, compare it to the player's cash. If it's greater, return a string containing the text expensive. If not, return a string containing the text affordable. Now we need a function that will change the appearance of an item button depending on its state. It needs the item button, and we can also pass the item folder and owned folder for the item type. First we'll get the item state using the function we just wrote. Let's get references to the item button's components. We'll start with the locked state. For locked items, the image should be black to hide it. I'll also set the text color to black. The name text should display question marks. We don't want to display any state text, so we can set its text to an empty string. If it's not locked, let's first undo some of the changes we might have made. Set the image color to white. And the name text back to the name of the item. Then we can handle the owned state. I'll make the state text green and display owned on it. If it's instead equipped, I'll display equipped on it. If none of the above conditions are satisfied, it leaves the affordable and expensive states. For both, the price will be displayed on the state text label. If it's too expensive, the text color will be red. Otherwise, it'll be orange. We also need to update item states when the player's cache changes or when they unlock a new zone. Make a function called updateStates that we'll call whenever we think an item state has changed. Inside, we'll iterate over each child of the storage scrolling frame. Make sure it's an item button by checking it contains a value called item, otherwise this code will be run on the UI grid layout. Inside, call setItemState as we did before. Now do the same for the flavors scrolling frame. We can call this function when the player's cache changes. And when a child is inserted into the unlocked zones folder. Let's handle displaying the selected item. We need to store the selected item button in a variable. If we don't, once we select a button and its appearance changes, it'll be difficult to change its appearance back when a different button is selected. We first need a function for when a locked item is selected. It'll receive the selected item button, get the item referenced by the button, then we can set the zone name text to the item's zone. Finally, show the locked container and hide the unlocked container. Let's make a function for when an unlocked item is selected. Set the item name text. We can just copy the name displayed on the item button and do the same for the image. Now we need to display the item's stats. If it's a storage item, we'll display the storage value, followed by the text storage. For flavor items, we'll display the bubbles per value, followed by the text bubbles, and prefixed by a plus. Since unlocked items have multiple states, we'll need the item state. First, let's hide all the state containers. We can then show the container we want to. If the state returned is equipped, show the currently equipped container. If it's owned, show the equipped container. Otherwise, show the buy container. Then set the price text to the item's price. If the state is expensive, set the color to the same color we used in the setItemState function. Do the same for the affordable state. Finally, hide the locked container and show the unlocked container. Now make a function to select an item, which we'll call when an item button is clicked on. If there's already a selected button, set its appearance to unselected. Then we can update the selected item button variable. And we can set the item button's appearance to selected. To determine if an item's locked, we can simply check if the item state text is empty, since we decided to do that in the setItemState function. If it's locked, call the setLocked function. Otherwise, call the setUnlocked function. When an item is selected, we want to scroll to its position. To do this, we can modify the canvas position property. We only need to change the y-axis since the scrolling frame is vertical. First, get the absolute position of the item button, which is its position in pixels on the screen. Then, subtract the absolute position of the scrolling frame, which gives us the item button's position relative to the scrolling frame. Then add the current canvas position, which will take into consideration if the scrolling frame has already been moved down. Right now, the item will appear at the top of the scrolling frame. We want it to appear at the center, so subtract half the scrolling frame's absolute size. Then add half the item button's absolute size. Now we need to use this function to display the player's equipped item whenever any of the pages in the shop are opened. To do this, we'll iterate over the children inside the scrolling frame. We need to ignore the UI grid layout, so check if the child contains an item object. Now we can compare the item to the currently equipped item. If they match, we can call selectItem for that button. We can also break to avoid unnecessary iterations. Do the same for the openStorage function. Let's move the openFlavors call to the very end so we don't have any issues with a function not existing because we called openFlavors before defining the function it needs. When we create an item button, we can also listen to the mouse button one-click event. Inside, we'll call selectItem on the item button. In the updateStates function, we also need to call selectItem in case the currently selected item state has updated. Let's test to make sure selecting works. Now we need to handle the equip and buy buttons. Let's make a function for equipping an item. It will get the item folder in the replicated storage. If it's a storage item, we can use the storage remote event. If it's a flavor item, we can use the flavor remote event. Now let's listen for when the buy button is clicked. First, we should make sure the player can afford the item, which is just a simple comparison between the item's price and the player's cash. If they can afford it, call equip item. Let's do the same for the equip button. First, make sure we can't buy something too expensive. Now we can go to the server view and increase our cash. Now let's buy it. As you can see, when I click on the equip button, the states don't update. We'll need a function to update the states when the equipped item changes. In the function, we'll start by calling update states. To detect when the equipped item changes, we'll listen for when the current equipped item's name changes. We need to store the connections so we can disconnect them later, or we'll end up with many unnecessary connections. There will be two connections, one for the equipped flavor and the other for the equipped storage. The connection uses once, so we only need to disconnect the other connection. Then the function will call itself to set up the connections with the new equipped items. Do the same for the equipped flavor. Now all we need to do is call the function. Let's test the game. First, let's increase our cash. Now the states update when we equip a different item. The next thing to do is changing the jump height in gravity. In the game properties, let's create a number value. Name it min gravity. This will define the smallest gravity that can be set. If we don't define a minimum, at some point the gravity will become so low that a player won't fall back down when they jump. Then we need a number value called base gravity. This is the gravity players experience when they have 0 bubbles. Create one more number value named gravity size ratio. This is the amount of gravity that is taken away for every bubble blown. Create a final number value named jump size ratio, which is how much jump height is added for every bubble blown. In the starter character scripts, create a local script. This container is for scripts we want to run for a player whenever their character spawns in. First, we need the game properties folder and the values we just made. Now let's get the player. We need the bubbles value. Get the character. And then the humanoid, which has the jump height property we want to modify. Now make a function that responds to when the bubble's value changes. First we'll set the jump height to the product between the bubble's value and jump size ratio. For the gravity, we'll divide the base gravity by the product between the bubble's value and gravity size ratio. This product must not be smaller than 1, otherwise the gravity will increase when the player has a small amount of bubbles. Then we need to make sure the entire thing never goes lower than the min gravity value. You can also decide to use whatever functions you want for deciding how the player's bubbles affect their jump height and the gravity. Now let's call the function initially. Then we can call it in response to the bubbles changing. When we spawn in, we have 0 bubbles, so we can't jump. When we start blowing bubbles, our jump height will increase. We can also set the bubbles value to something higher. We're already at the minimum gravity with only 5000 bubbles, so you might want to adjust the gravity size ratio value. The last thing we need to do is make the physical bubble. First let's hide all the GUIs. Go to Avatar and open the rig builder. You can create any rig, I'll just go with the block avatar. Go to the rig's head. Inside, create an attachment. Name it Bubble Attachment. This will be used to determine the position of the bubble. Move it on top of the mouth. Then we need to make sure it's facing forward. To do this, we can add a particle emitter to the attachment. Set the emission direction to front. If it's rotated correctly, the particles will emit forward. If it's not, you can use the rotate tool to correct the rotation. Once you've confirmed it's correct, remove the particle emitter. We need to put this in the templates folder. Because it's an attachment, it needs to be parented to a part. So let's create a part in the templates folder. Then we can put the attachment inside it. Rename the part. Now in the game properties folder, we need a new number value. Name it bubble size ratio. This is how much the size of the bubble model should increase by for every bubble the player has. We'll handle the physical bubble in the server script. First, let's get the bubble size ratio value. We also need the bubble attachment template. Whenever a character spawns in, we'll create the attachment. First get the head. Then we can create a copy of the attachment, which we'll parent to the head. We'll need the tween service to animate the bubble when it changes size. We can also make the tween info here, so we don't need to make it every time the bubble needs to be animated. Now make a function called setPhysicalBubble. It'll receive the player as well as a parameter called createNew. This will be true if we need to make a new bubble model, and false if we just need to change the size of the existing bubble model. First get the character, then we need the current bubbles value, now make a variable for the bubble model. It'll be null at first, since we're giving it a different value depending on the createNew parameter. If we need to create a new bubble, first look for an existing bubble. If there is one, we'll delete it. Now let's get the head and the bubble attachment inside. The bubble model is contained in the flavor folder in the replicated storage. Let's make a copy of the model. We'll use a weld constraint to join the bubble model to the character. Part 0 will be the head, and part 1 will be the bubble's primary part. Let's make sure the models have a primary part set. If not, set it to the main part in each bubble model. Finally, put the weld inside the bubble model. Now let's make a number value. Since we can't tween the scale property of models, we have to tween a value instead. We can listen for when that value is updated and set the scale then. First disable the weld by setting part 1 to nil. If we don't do this, changing the scale and position of the model can cause problems like flinging the character. Then we can use whatever functions to determine the model's scale from the value. I've chosen a logarithmic function, meaning the rate that the bubble grows slows down as the bubble's value gets larger. If we choose a linear relationship, the bubble gets too large too quickly. We also need to put a lower limit on the scale value. The lower limit must be greater than 0, because logarithmic functions don't allow 0 as an input. It must also be greater than 1, because log 1 returns 0, and anything less than 1 returns a negative number. The model scale property cannot be 0 or negative. Now we can change the model scale. We can't modify the property directly, we have to use the scale2 function. Now we'll adjust the model's position. We'll use the attachment's C-frame. The bubble model needs to be offsetted in the direction the attachment is facing. This is why it's important that the attachment's direction is correct. Multiply the look vector by half the bubble model's size. This is simply half the bubble scale variable, since we set the primary part size to 1 on everything, so when we set the model scale, that's also the diameter of the bubble. Finally, set the part 1 back to the primary part. Now parent the value to the bubble model so we can access it later when we need to update the bubble's size. Let's also set its initial value to the bubble's value. And parent the bubble model to the character. If we don't need to create a new bubble, let's get the existing one. Then we can tween the scale value. Call this function as soon as the player spawns with create new as true. Also call it in response to the blow bubble remote event. This time we'll pass false since we want to change the size of the existing bubble. Call it when a player sells their bubbles. We want to create a new model because we don't want an animation for the model scale going to 0. Let's test to see if it works. The bubble is not in the correct place. It only goes to the correct place once we start blowing bubbles. This issue occurs only when the player's bubbles value is at 0. Because the default value of a number value is also 0, if we try to set the value to 0, which is the value already, the event won't fire since the value hasn't changed. A simple fix is to set the value to something else before we set it to the bubble's value. Let's set the value to a negative number since the player will never have a negative amount of bubbles. Now if we play, it'll work fine. Let's buy a larger storage to make a larger bubble. We also need to call set physical bubble when the player equips a new flavor. We want to create a new bubble since the player will have a new bubble model. Let's unlock a zone by creating its value. Then increase the cache. Now blow some bubbles. Equip a different flavor to make sure it changes properly. Everything works fine, so let's end here for now. If you're interested in a second part, let me know by liking and commenting. Also comment any other video ideas you have, and you can join the Discord server to send your video ideas. Thanks for watching and have a wonderful day.